Hello, hi everyone. Welcome to the session.
Hi everyone, this is Kalai. Welcome to this session.
Kalai, you want to help us getting started over here?
Varun, can you share your screen? So,
Yeah, for sure. I'm gonna go ahead and share my screen. Guys, can you see my screen now?
I hope everybody seeing the presentation screen.
Can we get a little help from the audience here? Guys, are you able to see the screen? Justin? Okay, awesome. Kalei, I think they can see your screen, but I'll go ahead and move my screens and we can get started. So again, welcome everyone. Sorry for that technical glitch. Always happens when you haven't prayed enough to the demo gods. Glad to have you here. Today's topic, we're going to talk about the ingest and querying using Azure Cosmos DB for Postgres, which is our distributed relational database offering. And we are so happy to have you over here. Uh, a quick intro. My name is Varun Dhawan. I'm a senior product manager with the Azure Database Postgres team. We work on two different offerings. One is the distributed offering, which is how we horizontally shard Postgres, and one is our flexible server offering. Uh, yep, and that's what I do. And over to you, Kalai.
Hi everyone, my name is Kalai Shakarapani. I'm the principal cloud solution architect, and I'm going to be leading for the entire session along with you guys. So, hope everyone's going to be enjoy the entire session. Thank you for joining this one. Let's wait for to learn so many things about PostgreSQL.
Uh, do we have Jasmine? Jasmine, are you over here? You can say hi. Maybe she's on the chat. Okay. So let's go ahead and start with the learning objectives over here. So it's going to be a pretty straightforward sessions. I believe some of us who are on this call have already got some experience working on Azure Cosmos DB for Postgres. Uh, it's our relational database offering where you can use a relational database for horizontally sharding the data and make essentially make a relational Postgres work like a Cassandra or a Mongo, have the data distributed across multiple nodes. Now, this specific session is only going to focus on the data ingestion, which is like what are the some techniques of how do we get the data ingested into a sharded database, and then obviously once you have the data ingested, you want to know like where exactly is your data distributed and how you get the data back. So we are going to go through all those techniques and details, and we have a lot of hands-on which we are going to show. And I'm going to do a little intro and then give it to Kalei, to start us with the first module. So Azure Cosmos DB for Postgres, transform Postgres into a highly scalable distributed database by clustering many Postgres servers together. So let's just wait, look at this, take a moment, to look at this diagram over here. So think of this, as your standard Postgres table, like it's a payment table, let's say, and then you have a single node, which we're just calling a coordinator node over here. Uh, and then in a normal day, like this is your database. You just query this table, and you have 100 rows or 1 billion rows, and all the rows sits in this particular database, and you get all the data. However, the Azure database for Postgres, Azure Cosmos DB for Postgres, makes it a little different. What it does is that it internally has these additional databases, down over here. You see in this case, these are called worker nodes, and in reality, the coordinator node does not keeps the data. The data actually sits in these worker nodes. And what happens is our magic sauce, which is the Citus extension, what it does is that when you put the data in, when you store the data, then the data finally gets stored in these smaller worker nodes. It just gets sharded. Think of it as sharding, or think of it as like partitioning. It just partitions these data across these nodes, And when you query, like you don't bother whether the data is sitting on these worker nodes or 10 or 20 or 50. You always query as if like you're just talking to one single database, which happens to be your coordinator. And then internally, whenever you write query, which is like you are doing a select or you're doing an insert activity, which is the topic of the discussion over here, the data automatically gets divided or segregated into these worker nodes. So if you're inserting 10 rows, these 10 rows will automatically get distributed across these two worker nodes. When you are querying 100 billion rows, which is coming from these 50 nodes, we will automatically do all the combine and all the join, and will automatically give you. So for the application and for the end clients, this is transparent. With that, Kalei, I'm going to give it to you to start with our scenarios for ingest and querying the data across multi-distributed database.
Yes, sure. Thanks, Varun. So everybody's able to see my screen.
Kalei, I'm
Currently,
yeah, Kalei, I'm able to see ya.
yes. So right now, I connected, the Cloud Shell. The Cloud Shell is running my, PostgreSQL, and also I'm going to be run with all my scripting through the PG admin 4. Is that user interface? You can access your PostgreSQL from the GUI based graphics. Um, Let me share my PG admin. The PG admin, it's very easy to interact all your queries and everything. So let me share that screen. I hope everyone's seeing my screen.
Uh,
Varun,
no, Kalei, I just see a video. I don't see a screen.
sorry for the technical problems. It's sharing the
That's okay.
entire screen.
Yeah, that's okay, Kalei. Yeah, go.
Is it okay now?
Not yet.
Mm, sorry, Varun. Can you take it from your end?
Sure, Kalei. I'm going to take it from my end. Yeah. So
Yeah,
guys,
I can I can explain that.
yeah. So, Kali, why don't you go and explain, lead us with the first slide over here, which is the scenario of loading the individual rows.
Yes, this one is the simple insert queries. The insert queries is going to be insert with the values in the PostgreSQL. The normal insert command, take it for all the values and inserting into the table. We have created two tables. One is the payment events and the payment uses. The payment uses have for four columns, and the payment events contain for six columns, and the primary key would be event ID and user IDs. So the load insert command is loading for one values. That the one values one set of the rows is the with null values. The null values is not going to be load exactly. So when you come with the actual values for the user IDs, so with the actual values, it will update. It can insert your command to the table. From the PG admin, we can run through all the tables, all the queries, how we can distribute the values, how we can creating the tables, and how we can insert the values. It's just with the insert command, also for the bulk load commands. Insert commands we can run through the PG admin, and the bulk load we can run through from the cloud shells. Varun, can you take it?
Sure, Kali. Yeah. So the Kali explained, we can run through all these scenarios. So I think Kali talked about at least two different scenarios. So one is a very simple insert statement. So if you're using any relational database, be it Postgres, MySQL, Oracle, SQL Server, this is an insert statement that you would have seen. We are just inserting one row at a time. And I'm going to show you, how this first and the second insert is a little different. The other scenarios that Kali talked about is that you can also have this more efficient insert where you can insert multiple rows at a time. This is still like a little verbose, but yeah, you just type insert into and then you can add as many rows as you want. But the interesting things over here is that we are going to show you the bulk load where you can pretty much insert hundreds and thousands of rows, which is, comma separated values right over here. uh, and then finally, the last one, which is, we'll also show you the old classical insert into where you can read from one table. In this particular case, we read from one table payment event and we insert into user events. So these are pretty straightforward events. Again, we are keeping it very raw and fresh. We haven't staged anything for you. The only thing I want to show you is that here we have the Azure Cosmos DB. I'm going to make use of the screen real estate. So this is my instance for Azure Cosmos database for Postgres. The key thing to note over here, if I go to the scale column, again, I'm going to be slow over here, hovering my mouse. This is the scale blade experience. I have one coordinator node, which is like one single node, which is going to do the job of coordination. And then I have two worker nodes, which is like two nodes where the actual data is going to sit. So that's the topology of, my distributed architecture. Now, can I have more worker nodes? 100% yes, I can have uh, 10, 20, whatever is my workload. So that's the whole configuration I have. Other than that, it's a pretty simple, Azure Cosmos database for Postgres. If any of you who have this instance already, can also, play around, or you can take these scripts and you can work along. So let's come back. I have this database, I'm connected, and I pretty much do not have anything right now. So if I run a simple table from the information schema, uh, again, pray to demo gods, it works. Uh, I shouldn't have anything, created over there. Maybe I can also use a little cloud shell over here. So did not find any relation. So there are no tables over here. My query over here is still running. Okay, awesome. So there are no tables. So now I'm going to get started. So I'm going to create my first table. Nothing fancy about it. It's like a normal create table command. I'm going to create my next table and the third table. Okay. So till here, this is a standard Postgres command you would have done on any database. No big deal. The magic begins of the distribution over here with these proprietary functions, which is create distributed table. Over here, if you see, I'm passing within this function, I'm passing my table name and I'm passing a column, which is going to be my distribution key. So I'm going to create a distribution table. It's not going to give me an output. It's just going to be like that. And I'm going to create another distribution table, and that's about it. Now, if I run this query, which is select asterisks from citus table, it's going to show that, hey, you know what? I have two tables, and these are distributed tables, because in the citus table type, it shows distributed. It shows a distribution column, and then it shows some other metadata, which we'll go over in couple of modules. Now, I can create two different types of table in Citus. I can create a distributed table. A distributed table is a table which is distributed across nodes. Again, let's come back and just be on this screen so that we keep remembering that we have two worker nodes over here. This two sign tells. So, our distributed tables are actually distributed across two nodes. And coming back, and then if you create, we can create another type of table over here, which is a create reference table. Now, the fun part with the reference table is these are smaller tables, which you know normally reference. Let's say a city table within a state table within United States can be a reference table, given we have 50 states, and then you want to references in different part of your application. In an e-commerce application, you have the customers' addresses, and you have the suppliers, and you have items, and all of them want to reference same set of states. So you can create a reference table, and reference table, instead of getting distributed across various nodes, we keep the entire table. We make the duplicate copies of this table across all the nodes. So if you have 10 worker nodes, you will have 10 copies of reference table, which is kept across. And this is purely done so that once the distributed tables have to use the reference, they do not have to do costly join, and they can just reference, locally. So I'm going to create this reference table over here. This is done. Again, I'm going to do this citus table thing. It should show me something, so obviously it shows me there are two tables distributed. One table is reference, and since reference table is not distributed, there's no distribution column over here. And then this is where I'm going to begin. So, uh, Clay, are you still up for running, or should I go ahead run with the insert command?
I think you can run it. I have some technical challenges here.
Okay, sure,
Probably I can come back and talk about for how we can insert with Azure Data Factory. And
sure, Clay. Yeah. So I'm going to insert one basic row. So my row is inserted. Nothing big over here. It's just one row. How about I insert two different rows over here at a time? And now if I look at the events, like I can see, that yeah, these rows are inserted in the payment events. Hold on. Did I insert? Okay, so I think these inserts already worked, and let me see whether this insert really worked. Okay, I think I had a little error going on over here. Awesome. I should be seeing three rows over here. Boom. Yeah. So I'm seeing three different rows which I've inserted. Now let's find this fun situation. So I'm inserting into the payment events. I have pretty much, exact same values that I have in the single insert. The only thing I did was for one of the columns, and that one of the column happens to be the user ID column in the payment event table, which, by the way, if you remember, is also the distribution key. So if I come back to the citus table over here, this is the distribution key, user ID column in payments event table. So now if I omit this column and then try to make an insert, and I just say, well, I don't know, I'm just going to do a null over here and just try to insert, I will get an error which says error cannot perform insert with the null in the partition column. So this is important. Like if you were doing a default partitioning in Postgres and you do not provide a partitioning column, I don't know, maybe it goes to a default partition like a catch-all partition. But inside us, if you're trying to insert the data in a distributed table, which obviously has a distribution key, then you got to specify that distribution key during the insert. So that's important. So it's an important call out. So we've been doing these small insert. Now let's do some big inserts. So I'm going to open this and going to show you that we have this big CSV file right over here. So I'm going to open the CSV, uh, and I think it probably has some 200,000 rows over here. So what if that now I want to insert all this data in one single go? So well, we can do it. Uh, I'm going to do this from the Cloud Shell. So it's going to show you a flavor of Cloud Shell. So Cloud Shell uh, is pretty much integrated. So you can just hit over here and you can just open a different Cloud Shell. So this will open a different Cloud Shell window right now over here. But I have opened a separate window just for the sake of, easy visibility. And then I've already logged in. So, I can, if I do pSQL, I'm just kind of, already logged into my database. This is the same database I'm connected. I have same tables which are going on over here. So now I'm going to run these commands. I'm going to set client encoding, which is important just in case to be sure that what is the client encoding for my CSV file. And then one at a time, I'm going to run these copy commands. Okay, seems running. Whoa, so I think I just inserted 264K rows in probably less than a second, how about the populating the next table, So, and I am now populating the payment events table, again inserting 126K rows again in less than a second. And yeah, that's pretty fast. And now let's be back and I'll do a simple count. And I have 264 rows going in the payment users and I have 126 rows going in the payment event. I think I don't know. I'm maybe going fast or slow. Feel free. Kalai is watching, the comments. So if in case there is anything that you want to stop or ask a question, feel free. But that's how, the distribution is going so far. And then I'm going to create one more table, which is user events, right? So I have three tables. Let's come back. I can just do a dd plus. I have, some data which is going on over here. If you see, these are all heap tables. Uh, One more method of inserting, which we want to show you. So far, we've seen you that you can do a basic insert, you can insert multiple rows, and then this one is cool that you can do this bulk insert using the copy command, which is very popular in Postgres. One additional option to insert is that you can also insert, you can also always read the rows from an existing table, right? And then you can always insert them in the a different table. And again, like this is nothing which is specific to this Azure Cosmos Postgres. You can do it pretty much in any standard RDBMS using the insert into. So we have this table, user table. There's no data in it, and yeah, obviously, I'm just going to first show you the user events. This has to have 0 rows over here. So now I'm going to say that insert into user events and select some data from payment event. And when I say some data, is because I'm doing an inner join over here where some join condition is meeting. So I'm going to do this command. Okay, it says some 61K rows updated. So let's go and do an select, and then we see the user events is populated.
So very
With that,
interesting.
yeah, Kalai, go ahead. I'm going to be on this slide, which I just summarized for you. You want to summarize this, what
Yeah,
the exercise which we did, yeah?
yeah. The exercise so far, what we did it, so we can use for insert command, for single row, single values, and also if you have for more larger volume of records or data, you can use through the bulk load. Bulk load, you know, you can use is a cloud shell. The cloud shell is the integrated, interface is part of the portal, and it runs, short time of, time to be upload and insert all your record like milliseconds, maybe 20 milliseconds and 40 milliseconds based on your volume of record. And once you have the volume of record, you can keep that record as a table, and you can select the table values, insert your all the records from one table to the another table, selecting the values, then insert to the new tables. And other way you can do it through the Azure Data Factory. The Azure Data Factory is the cloud-based integration services. That's everyone knows that is a low code or no code visual environment for orchestrating and automating your data movement. So ADF is Azure Data Factory. You can use as a linked service for PostgreSQL, then create the data set. From the data set, you can insert all the values like copy command, copy activities like source and sync. Source would be could be for your all the records. Maybe it's a .csv file or Excel file or text file. You can use as a sources all plot files. Then you can insert your tables as a sync. Sync would be your linked services is PostgreSQL. The it's so many ways you can insert your record to PostgreSQL, and if you want to use this automated data injections, you can use Azure Data Factory as the injection for all your inserting commands and inserting tables to the PostgreSQL. Back to Varun. Thanks for that.
Yeah, no, appreciate Kalai. Thanks for explaining again. Like, yeah, we couldn't have, compacted all those things, but besides the regular options that we've shown you, yeah, ADF and also ingesting using other Azure services, these are always an option. So now that we have already inserted the data, so here's the summary of the exercise. We've created some tables, we've distributed the tables using the create distribute, and we did a lot of inserts. We showed you, if you insert without the distribution key, you run into an error, which is expected. And then we showed you the bulk loading and populate table using the from select command. The next thing is, okay, well, data is now there in the tables. Uh, I want to understand, like, this is a distribution architect, this is a distributed architecture. I want to understand uh, how is the data distributed? Like, show me the metadata. Like, how can I tell, how is the worker nodes keeping this data, and how is the coordinator node using them? So let's dive into this part. Uh, so the purpose of this exercise is to have use the coordinator metadata tables and views to understand the data distribution. Again, the scenario over here is our fictitious bank, Woodgrove Bank, have asked us to review and optimize query execution for the distributed tables, and we're going to go about doing that. Uh, Okay, and then so let me go through the slides first, which is a little easy, and then I'm obviously also going to show you all these things in details. So again, like find the distribution column of the distributed tables. I think pretty much I showed you. I'm tempted to go back and show you again over here that you can always query this metadata view or a table, which is cite as table, and you will always get that whatever tables you have, whether they are distributed. If yes, then what is the distribution column, what is the co-location ID, table size, uh, how many shards are created, all those things you will get all that metadata information over here. Again, in this particular case, we are just seeing this example for one table. The next one is you can also discover the information about the nodes in your cluster. Now I'm going to show you two different ways to do it. Like obviously the first way is, and the most recommended, uh, if you are a command line person like me, is you just simply query and you do it from pgdist node. Maybe at this point, I don't know, I'll go and switch and show you that I can run this, pgdist node, and it shows, that there are nodes over here. How about I, for the better clarity, I can run this query, from my cloud shell. Awesome. And a little
Great.
X.
But really is very great. So looks like you can insert for all the records.
Yep, yep. So over here, now I have, I'm just querying, PG disk nodes, and it gives me, three different records. So I have a node ID 1, node ID 2, node ID 3. Now remember, one of this node is a coordinator node, and then remaining two nodes over here are worker nodes. And the reason I was saying that there's a different way to do this, again, if you come back to your Azure portal, uh, go browse to the Cosmos for PG, and then you will see the nodes over here. You will get all the settings and all the parameters over here. So you have two worker nodes and you have two coordinator nodes. Coming back to the PPT, just trying to stick with the flow. You can inspect the data skew. Uh, so once the data gets inserted, and you have two nodes, and each node has 32 shards. How do we want to make sure that are all the shards and all the nodes are filling up evenly, and it's not that there is a skew whereby you have one node filling up data more than the other? Because if that happens, uh, what about, like, you have, say, same storage, you have a 10 GB storage configured for all nodes, and you expect that if each of these 10 nodes fill completely, then you can easily have 100 GB data, 10 GB for 10 nodes. But what happens in a case of a skew is that your one node fills up more than the other, and maybe that reaches a 10 GB limit and it stops ingesting, whereas your other nodes are not proportionally filling. So that's a data skew condition, and we have a query, to view the data skew. So maybe I keep walking along as I'm doing this, so uh, so that I'll keep showing you the data skew and everything. So you can use the distributed table view, citus table. So this is again the table which I've been showing. Let's stick to the payments event. So payment event table, and our distribution column is user ID, and our total table size is 26 MB. Remember, we inserted uh, tons of rows, after the bulk over here. So I think it has probably 126 rows, so which is why you see a little size over here.
So
We
Varun,
just
Varun,
gone through the PG disk nodes. We just see, that one of the nodes is
Varun, it's a quick question. So, can we add more worker nodes?
Go ahead, Kalai.
Can we add more workers node?
You can definitely.
It's more than two nodes,
That's a good question, Kalai. You can definitely. Yes, yes, you can definitely add more than two worker nodes. And once you add more than two workers node, even when your database is created and your data is already sitting in your two nodes, and let's say you decide to add one more node, we have something called an automatic load balancing, and we also have a manual load balancing. Over here, there's an experience called shard rebalancer, and it will tell you, that uh, whether the rebalancing is required or rebalancing is not required. And if you want to do a manual rebalancing, you can automatically do the rebalance.
Sure. Thank you, Varun.
So yeah, so I have these two nodes going on over here. Uh, and then I think let's sync back to our slides. We were talking about the data skew.
Mhm.
I see a little background. Okay, yeah. So I'm going to show you a data skew right now. So let's look at the few records in the PG distributed shards. So this is our PG event table. Uh, this is our shard ID. This is our shard storage, minimum value and max value. Now I see a comment somewhere. Somebody posted, Sam 16379. He says, so in Synapse, distributed keys like hash distribution and reference table is like replicated. Do we also have a round robin distribution over here? So first of all, it's a great question. The second part is yes, it's pretty much the same architecture over here. That this is a hash based sharding that we automatically create hashes for shards, and these hashes are ranges. In simple terms, you have 100 million rows. We create 32 shards, and we say 1 million to 5 million will go in this shard, 5 million to 10 million go in that shard. These are just ranges, but these are hash ranges and not really a number range. And then whenever you insert a row, we hash out a value based upon, whatever is your distribution column, and wherever the hash, whichever range the hash belong, we'll insert that row in that particular shard. And to look at the data distribution, this queue which I was talking about, you can look over here. So I'm looking at the table which is payment users this time, and I'm looking in the first 10 rows and see what is the data distribution looking like. So you see, the data, this is my shard ID, this is the shard name, and this is the shard size. And if you look closely, maybe how about I can copy this and run it over here in the cloud. So I'm going to turn off the X and then copy this query. Did I? Okay, really? Yeah, it's a little tricky to copy and run it in Cloud Shell sometimes. So I'm going to do a pSQL backend. Awesome. So if you see over here, I have the shard IDs and shard names and shard size. The thing that I want you to concentrate on is, first of all, I'm only doing it for 10 shards because I've done a limit of 10. The thing I wanted you to concentrate is the shard size, that how when we are doing this distribution, we are inserting these hundreds and thousands of rows, how Citus, is making sure that my all shards are equally populated, so which is why the shard size, if you see, are mostly the same. They are not exactly the same, but they are very similar. So this is how the shard rebalancing makes sure, that no one single shard fills up more or less than every other shards. Again, why is this important? We want to make sure that your shards fill up evenly all across, so that when you're inserting data and when you are querying the data, all the shards and all the compute resources are evenly used, rather than one shard or one node, getting used. I'm going to say, if you have a shard skew situation whereby only or one or two shards are filling, then essentially, you are not even leveraging the distributed architecture of the posters that we are implying over here. Okay, Kalai, yeah, watch out for questions, and if there's anything, feel free, Kalai, we can go over that question again. So we
Yes,
so
that
we've
sounds good, Varun.
so we've
Varun,
gone. Yeah.
So far, what we've seen here, data load into distributed tables, right? We have created tables in the database and distributed the tables and inserted the payment data, and also, we can populate all the values.
That's right,
How we
Kalai.
get, yeah, how we distribute it towards the nodes, like worker node and the control node.
That's right, Kalai. So what's the question, Kalai?
So we want to make sure what we done so far, the exercise, how we distributed the values towards for within the worker nodes.
That's right. Yeah. So in the first step, we inserted tons of rows, especially using the bulk command like 126 or whatever. And now if you come over here, that's what I'm showing, in this particular query, only if it obeys my command over here. If you see, all the shards, are evenly populated with, with whatever data which we are inserting. The other way of seeing this data distribution is with another experience, which is, this shard rebalance. Which shard rebalance also shows, that where are our nodes and how much is the node size. And right now you see there's no movement. Otherwise, when you have a data skew situation that you just happen to insert, bulk load the data, and you have data going into one shard or one node too much, then there's this automatic load rebalancing which will kick in, and it will automatically start rebalancing and moving the rows across so that your nodes are enabled. And that's exactly my slide is that you can also, you can do this from the Azure portal, which is nice UI experience. But if you want to do it using the code, then we have the rebalance table shard function also, which you can use to rebalance the shard. Okay, I guess I'm on slide 27. Okay, and then fix the data skew with the shard rebalancer. Again, we are seeing this is the same output we get because our data size is minuscule, mostly 200 or 300,000 rows over here. So it says rebalancing not recommended at this time. But if you want to rebalance, you can always come and you can do a manual rebalance of the shards. We can always identify shard placements. I think I have a query going on over here for the shards placement over. So let's do this query to see the shard placement. So you can see what I'm doing over here is I'm going into this two tables, distribution placement and distribution nodes. And I'm trying to see, for a distribution column, payment users, and especially, payment users, and 5 is my distribution ID. I want to see where exactly this particular row or this particular piece of data is located. So it tells me, well, it's on a worker node. This is your node name. It's on a shard ID, so it gives me exact shard ID, and it also gives me a placement ID. So I can identify this is all the metadata, and this is all thing that I can locate where exactly is my row located when I have multiple nodes, multiple sharded nodes over there. And so we've just gone through the shard placements. The next one over here is useful diagnostic queries. Now, in addition to the metadata tables and views, there are many other diagnostic queries that are beneficial for understanding how your database is performing and troubleshooting issues. Let's go through some of these diagnostic queries I've set up over here. So one is the active queries, which is like the Citus stats activity view shows which queries are currently executing. Let me pull this down the next row. So you can filter to find actively executing ones along with the process ID of their backend. So let's see what is happening. So let's just query it everything, So what is happening in the Citus stat activity table? So this is just like, PG, you're just going through PG start statement and see, where exactly your start, what is happening inside the process of PG starts activity. This is cite as specific start activity that how your shard rebalancing is running. Now, again, like if you see technically right now, lot of I'm not doing many things and I still see, there are many queries that are running. The reality is most of these queries are idle. and some of them are active. So let's filter out the ones which are not idle. So these are my active queries. Now, what exactly could be happening over here in this query is like over here, if you see, there is a little bit of a short road rebalancing or internal activity which is going on. And we see, the states is active. So again, a very commonly used table, which is cited stat activity, which is very similar to PG stat activity. And again, if we see something is waiting, which is like, why is something waiting? So this is the another view, which we are going to say. So again, it's the PG start activity instead of cited start activity. Uh, and then we are going to see why is something waiting. So right now, I think there's probably nothing waiting over here, and there's nothing which shows, but uh, these are two metadata tables that you can use for troubleshooting the queries.
So, Varun, can we use the waiting one currently we see for ideal state? So, is there any way we can see for the waiting one?
Yeah, so right now, currently nothing is waiting. Maybe I don't know. How about should I insert something again and then see? Uh, Maybe yeah. It's like we can insert. It won't allow me. I have to truncate these tables. But if I were to run this bulk command again and then again a lot of rows, and then if we come back to these views, we will see that why is something waiting and why is something idle. Yeah. Right now, because there's nothing waiting, the things are empty. We don't have a lot of work right now which is going on over here.
Good, thank you, Varun.
Yeah, sure, Kalei, and thanks for pausing me if I'm going too fast or slow. Uh, I'm going to take a pause over here. Just go over. So in this the second part of the module, we just explain you again, like one thing which I should be showing is connecting using cloud shell. Maybe I'll just take a pause and show you, but overall we went through, we understood how do we examine the nodes in the cluster using that PG citus nodes, which is the PG dist nodes view over here. The other part which we learned is inspect the table distribution. We again went through the table distribution using all the distribution chart IDs, and then citus shards. We use all these tables to understand the distribution. And then finally, we inspect the distribution data. Is like we went further down and we were inspecting how the distribution is happening. Like we were able to pinpoint where exactly this specific row is running. And in addition, we saw some diagnostic queries whereby obviously, if you've been using Postgres, you would have 100% use PG status activity. And then this is a citus stat activity, which is citus specific view to complement PG stat activity. I want to show you, take a little tangent over here and show you the fun part of connecting to Azure Cloud. Uh, Kalai, how are you placed with? You want to? Will you be able to show, or I can show this part very quick?
Varun, still I have technical challenges.
Okay. Yeah.
It's asking me to restart my system, so that's why I'm not able to share the screen.
Yeah, no problem. Yeah. So I have a different window open, but some of you, if you haven't used the Cloud Shell, so let's say I'm in the home page of my Cosmos PG, right? For opening the Cloud Shell, see there over here, there's a little button. But even before maybe I go over there, you see there is a connection strings experience. I'm using an extension which is hiding the sensitive data, but otherwise you will normally see, you will see connection strings, popping all over here. So this is my connection string. Maybe if I copy it and put it into a notepad, this is my classic connection string. You see? Yep. So that's my connection string uh, right over here. So if I were to connect, I'm going to use this connection string. If I were to connect using Cloud Shell, I'm going to simply do a Cloud Shell button over here. Okay, and then I can obviously do this connection string. I have to put in my password over here. Alternatively, I can set the Cloud Shell parameters which I have already put in over here. If you allow me a minute, I can set up these environment variables over here, right? And then I can simply pSQL because my environment variables are already connected. I can simply pSQL and I can simply go into this. And the fun part is, if you want, you can always spin your Cloud Shell window, uh, and you can always open it in a different dedicated browser. That way, instead of a half an app screen, you can get a full screen experience over here the way I am having. So maybe I'm going to copy this. If you want to do that, I'm going to paste this link, or Kalei, if you can paste the link of msportal.azure.com's-cloud shell. So that's a little tangent on the Cloud Shell, and then we have one last part of the module to cover, which is now we'll go through the understanding the distributed query execution. So again, let's summarize. So in the first part, we put in a lot of data. So a lot of data went inside, our database, and this is a distributed database. So we showed you how when you're doing these inserts and bulks, your data is spreading across multiple nodes. Uh, Actually, I should be on this diagram. Yeah, let's leave this running. Yeah. So you're inserting the data. This is a coordinated node and it's distributed across multiple nodes. Uh, and then we showed you in the second module is a lot of metadata queries to understand how is like the data distribution happening. So uh, how evenly the shards are filled, how can you identify the skew between the shards, and how you can identify the activity which is going on using citus start activity and pg start activity. Now in this final module is all about, okay, well, my data is already there, now I want to start querying the data, right? So the data is in reality sitting on these worker nodes. So when I query, the question obviously is that do I need to know which worker node which I need to get the data out, or that is the secret sauce, which citus help us, with the distribution. So obviously the answer is the later part. You don't have to be there and identify which worker node is your shard sitting. You are always talking to coordinator node, which is like as if like it's the only database that exists in your architecture. And all internally it's going to do is that it internally keeps a track of where is which data and how it identifies. So now this module we are just going to go and deep dive on that part. So there are two parts to it. When you're querying the data and you're working with the distributed Cosmos Postgres, uh, learn how to distributed queries in the Cosmos Postgres. The coordinator node, like this is the key part, the coordinator node uses a query processing pipeline consisting of two important components. One is the distributed query planner, and the other one is the distributed query executor. So for each query, like for every single query which is issued to the cluster, the coordinator consults the metadata table to first build the execution plan and then passes on the plan to the executor for execution. So in a classic case, you just in a single node Postgres, you just have the query planner, and query planner just goes and builds a nice plan and fetches the data. In this particular case, that step is divided into two different pieces. So one is the distributed query planner, and the other one is a distributed query executor. So first we created a distributed query plan, which is like a query plan that clearly tells that uh, if I have 20 nodes and I have to fetch like 100,000 rows, how the nodes, which nodes I have to contact, to make sure that I get all that data in the most efficient way possible. So that's the distributed plan. And then from the distributed plan, on the worker nodes, which are technically also Postgres nodes, will have the standard, query which is getting executed. So they will have their own query plan which is going on over there to get the data efficiently from there. Now we have the data coming out of, let's say, 20 nodes. Then there has to be something that combines this data and returns this data as a single set, to the executing client or application. So which is why if you see this little GIF animation, this arrow says that, okay, well, first I send the query to the metadata and that it sprays out over there. So it sprays the query into these three worker nodes. and then at the return time, it again get the data from these three worker nodes, combine it, and send that one single feedback, to the application, making this query call.
So, Varun, the quick question, Varun, uh, for the distribution, it, do you have for round robin distribution, or how we can distribute towards for snaps, in snaps?
Yeah, so I quite honestly, I read that question, and I don't know the answer back of my mind. I don't want to, comment, so maybe I'll get back. But we do have an algorithm to make sure that distributions happens evenly. Uh, I don't know what distribution architecture we are using. Are we using a city hash or are we using a different algorithm? I can get back on that.
Sure. Thank you, Varun.
So we were talking about the distributed query planner and distributed query executor. So let's see these components one at a time. So what is distributed query planner? So the planner breaks the query into the coordinator query, which runs on the coordinator, and worker fragments, which runs on the individual shards. Now, query fragments are assigned to the workers to allow their resources, CPU, mem, and IO to be used efficiently. So that's my regular query. That's the query that we expect the application to be sending to Citus. So you will write a simple query like select asterisks from payment events, which is like select, give me all the rows. This is the standard query. What coordinator node is going to do is it's going to fragment the query because it says, well, you know what? Uh, to be able to return all the rows from the payment event, I have to get the data across these four shards, and these are the shard boundaries or whatever. Uh, Shard numbers, let's say. Uh, and these shards are spread across two worker nodes. So I have a shard ending with 104 and 106, on this, let's say, node A, and I have shard ending with 105 and 107 on this node B. And I'm going to distribute this query and make it convert into these four different queries. And now these four different queries are going to, so two of them are going to node A and get the data from there, and then two of them are going to node B and get the data from here. What is happening in this particular case is that besides the data is distributed, so you're using the power of distribution over here, is that right now the coordinator node is not busy. It has just offloaded these queries to these worker nodes, and these nodes are own separate computers, own separate servers with their own CPU, memory, and IO. So instead of 1 million rows being returned from one particular server, now you have three nodes or four nodes, or depending upon how many worker nodes you have, the CPU and the IO and memory and everything, resources from these nodes are being used. So you're not constrained by resources. So that's the key part we want to make sure with this whole distributed query planner and distributed query architecture is that we evenly spray the query so that the resources get used and not constrained at one particular server. So now, okay, fine. So I've done the query planning. My distribution query is ready. So what is the role of the executor, which is the second component? So Azure Cosmos DB for Postgres uses a distributed query executor to split up regular SQL queries and run them in parallel on the worker nodes. So I have the select events. My query planning is done. Now my executor will kick in, and my executor will make sure it does a little bit of clerical tasks. So it's going to make sure that I'm going to run some of these queries in parallel. And the key part is the query executor creates a connection pool for each session, opens up a connection per shard to the worker needed. So within a node, let's say if you have 10 shards, it's going to create a session pool, and it's going to create a connection per pool, and that's where it's going to make sure that all the queries are running simultaneously, and you're not if you run sequentially, then you really have to wait, which is like super bad for your query response time, and you want queries to be running blazing fast, and which is why we make sure with the distributed query executor, things run in parallel. They use resources in parallel, and when they get the data, we quickly combine the data set. That is the coordinator job, and then return the data back to the application. We are going to see this a little bit in action. And then again, like how to tell, I'm going to say this is all the magic which is happening, but how to tell, that things are running. So there are obviously explain is the way that you get the explain plan for the query. So you can help to gain insight on the query performance and query planning, and explain output also shows how each worker node processes the query and provide you some details about the coordinator nodes and combine the results. So this is a standard query, and if I just add the explain verbose, it's going to give me the explain plan. Actually, at this point, I'm tempted to switch to the screen and start showing you, some of these queries. So I am in the third part of the module. Again, just one thing, that all these exercises are available. I'm going to show you the link in the end. You can copy all these queries and run it, try it at your end, including uh, these table schema and including all the bulk loading, so you can really try all this data.
So, Varun, can we share uh, the slides also, right?
Yeah, we'll 100% be sharing the slides also in the end, Kalaya.
In the end, okay.
Yeah. So again, I can run this from Cloud Shell, which I showed you. For now, I'm just running it, from my local Postgres client. So in the Cloud Shell, run the following query to determine the distribution column. So I'm going to see the distribution. So I have, again, this is the old Citus table column and Citus table and three tables, and I have the distribution. Two of the tables are distributed by user ID, so nothing new over here. Note that distribution column for each table in the query output. Now I'm going to run some queries and maybe a complicated ones. And one of the complicated queries is when you join, tables. So I have a payment event tables, okay, and I'm joining it with the payment user. So technically, what I'm doing is I'm joining two different distributed tables. Uh, uh, who knows? These can be co-located, means they can be on the same worker node or they cannot be on the same worker nodes. So if I do a left join and I make sure that user ID on both this is same, what is going to happen? I'm going to take a pause. Does anyone wants to volunteer answer to this? Okay, if you find the answer, put it in the chat. But the question again is that if I'm doing a left join on the distribution column of two distributed tables, the chances are that they will be on the same table because the distribution column is same, so they will be co-located and they won't be spread across. So if I'm going to run this query, okay, I get this query, so I get whatever I was looking, event ID and whatnot. And then if I run the explain of this query, which is the verbose plan, this is where I get the explain plan. uh, can I think that's the best zoom I have. The key part over here, and maybe I have this in the slide, is to pay attention to the place where it says custom scan, and then in bracket it says Citus adapted, and this is where the Citus extension is kicking in. And it says, well, I'm going to do remote scan, which means I'm going to scan all the remote nodes. And remember, I have 32 shards, so it's going to go and it's going to scan all the 32 shards, which to me it's not very efficient. It should be knowing where exactly which data is, and uh, and then it's going to get all the things out. The key part is also that we are not putting a where clause. We are just combining the left join, so it's probably scanning from everywhere. So that's what I show in the note right above in my note section, the output query that shows that it was fragmented. Fragmented means, that the query is fragmented and it ran across these 32 nodes, which is the Citus adaptive scan, which you see in the row 1, 2, 3, and 4. That's the output of row 1, 2, 3, and 4. Now I'm going to do something called a repatriation join. Now, repatriation joins is when you temporarily. Let's first temporarily revert this table, and I'm going to explain you in a minute what is a repatriation join. I have written a little piece over here. Uh, so yeah. So this is how what is the explain, and maybe I can copy this piece over here a little bit.
Varun, sorry for the interrupt. So, is there any way can custom scan can do it here?
Say that again.
It's a custom scanning. When you're running your query planner, when you run this query, can you use for custom scan?
So yeah, so this Khalid, the custom scan, is our own query operator, which basically shows, which basically is, indicating, that we are doing, we are scanning through the rows, but instead of a standard Postgres scan, which means that we are scanning all the rows everywhere, and we are not using basically an index scan. Custom scan, is like we are going through all the shards, our distributed Postgres using the Citus adaptive, and we are scanning through all the shards and all the worker nodes. So that's the indication of the custom scan.
Sure. Thank you, Varun.
Now, regarding the repatriation query, this was a little difficult for me to remember, so I made a note of it, which I copied over here. So I'm going to go over. So Citus allowed distributed data and queries across multiple nodes for improved performance scalability. We talked about it. So by default, Citus is able to execute join operation between co-located tables, which is exactly what we did over here. We were able to do a join on a co-located table. That is when tables are matching records are on the same node. However, for tables that aren't co-located, Cited needs to temporarily redistribute the data in order to perform a join operation. So it's going to do it on the fly. Now, when Citus enable prepartition join configuration is set to on, Citus is allowed to redistribute the data to perform the join operation between non-collocated tables. So which means first we'll pick up non-collocated tables, we'll try to do a join uh, with the repatriation join off. If it is off, it's probably going to give us error we are going to see, and then we'll try to turn it on, and then we'll try to join again, and then probably it's going to give us on. The key part to understand is that this process is known as repatriation. This is usually necessary when you have large table that needs to be joined on a non-distribution key. However, repatriation can be resource intensive, which is why it is not enabled by default. So technically what is happening is that when you're joining on these non-collocated tables, uh, you have to anyway get the data out. But for getting the data out efficiently, Citus has to move, these data on the fly, uh, and then make a join, and then obviously that's a penalty, and it takes up CPU and resources. So by default, this is not on. So if you were to absolutely necessarily do this in your application, which is write queries which are joining the data from non-distributed, non-collocated tables, you have to manually go and set this configuration to on. So the command set Citus enable partition join Oz is telling Citus that it is allowed to redistribute the data for the purpose of performing join operation, which can allow more types of queries to be executed, but may have implication of the performance. So which means what we are suggesting is do this for a purpose, and then you can also turn it off. So let's now delve into this. So for the purpose of this demo, we have this payment merchant table, which is distributed over here. We saw, let's run it again. So payment merchant table actually is actually not distributed, so it has nothing over here. So maybe if I run this first command, it should give me not distributed. Okay. So anyway, I undistribute this table, and I'm going to distribute this table again. So now this table is distributed on merchant ID column. And now that I have a table, I'm going to use a screen real estate over here. Now that I have a table to work with a different distribution column, run the following query to observe the results. So I have taken a payment event and I'm combining it with the payment merchant. And this is non-collocated table because they have different distribution keys. Again, let's come back. Let's keep observing distribution keys over here. So I have payment merchant, which is using distribution key merchant ID, and I have payment events, which is using distribution key user ID, and payment users is using user ID. So when I'm running this type of query, which is I'm combining payment event with payment merchant, they have different distribution IDs, so data will never be co-located. So let's say if I run this query, it actually gives me error and it says, well, complex join are only supported when distribution tables are co-located and joined on distribution column. The data over here is not co-located, and I have not set the repatriation join on. Now let's say attempt join using inner join, probably still error. I cannot do an inner join also. If I set the Citus enable repatriation join on, now it's probably going to help. So now if I try to do the inner join, which I was trying to do again, let's see. Well, it's going to take a little time because it's moving the data across, but it gives me something. Again, there's no data right now, but it gives me that query runs. And if I do an explain of this query, this shows me again that first it's a custom stand. I'm going to cite as adaptive, but it shows, well, hey, you know what? For one table, I'm picking up 32 shards. For the other table, I'm picking up 12 shards, and I'm combining them, and that's how I'm going to do. So it says in the explain output, notice the task aren't supported for repatriation queries. You can see map merge job over here. You see map merge and map merge job that coordinator used dynamically to repatriate the table to perform the join operation. This shuffles the data between nodes to explain the slowness of this query, and this is the important part. So when you are doing this, you can expect some slowness in the query. So there absolutely have to be a reason when you want to do this. And obviously, yeah, there is a little cleanup involved, but I'm going to take a pause over here. We are at 105 marks. We have exactly 25 more minutes to go. Let's come back and complete the slides, and then Kalay, I'm going to hand it over back to you
Sure.
before we take questions. So we've gone through, distributed query execution. We explain, you do this, explain plan. Obviously, you will be doing explain plan for your Postgres queries, but except that when you do explain plan on Citus, you expect to see, something like Citus adaptive executor, showing in the plan a lot, and it will show, how many worker nodes and how many shards, it's performing this query. Now, there are a couple of recommendations that to achieve the maximum query tuning, we tell you, that you can tune the parameters, and you have two different set of parameters. You have coordinator node parameter and you have worker node parameters that you can tune over here. So again, let me use screen real state, and you have coordinator nodes parameter, which is tune the parameter of your coordinator node, and then your worker node parameter, which will tune the parameter of your two or three or whatsoever worker nodes that you have. So yeah, so there are best practices, and you can read our document and go over them. And then finally, to achieve maximum query performance by tuning parameters, again, we also recommend you to make sure that your networking and everything is correctly set up. You should have enabled the access to all the worker nodes, and obviously you have to allow public access for you yourself, to connect to that node. I think that was pretty much the three main things. We already covered joins. We showed you, how you do co-located joins, and how
The,
you do and how you join, how you do the repatriation joins. Yeah.
so these joins are, the traditional joins, how you can create joins between the tables, you
That's
know,
right. That's
yeah,
right, Kalaya. Yeah.
yeah, this,
Just, just
what are the methods, everything.
yeah. Just key thing to remember here is that you can join between tables, distributed tables,
Hmm.
when they are co-located, and they will naturally just work. But if you were to join between tables that are co-located, then by default join will not work, and you have uh, to enable this set repatriation join on parameter, and
Hmm.
then you will join. There is a little performance penalty. So again, like this you will only do in certain situation, and then you can always set this back to off. So if you were to run this query in your application module, I think you will have a setting like set join to on. You will run this query, and then you will have set this to off, and you will run this in one single batch. All these three things.
So, is there any way can we join for non-distributed tables?
Yeah, that's so you can join from non-distributed table, yes. So a non-distributed table will then essentially be the reference table, uh,
Hmm.
which I showed in the beginning. That the other type of tables is uh, this kind of a table, a reference table, and
Hmm.
reference table is like a small table. Let's say all the states in US. Uh, and the reference table by default is duplicated across all the worker nodes. So that's your non-distributed table, and you can join. Since it's anyway, between all the nodes, it's co-located kind of, and you can easily join it. Yeah, obviously
So,
you're going to have the join key, but you can definitely join it. Yeah.
So one more question, Varun. So repartitions tables, we need to enable it by default, or we have to be enable it.
Yeah, so repartition by default is turned off, and I think I explained this in this slide. Let me go back over here.
So it's manually we have to be turned on, right?
Yeah, like the repartition, I think maybe it's there in my notes and not really over here. Yeah, so we say over here that repatriation by default is turned off. This is
No.
usually necessary when you have this. However, repatriation can be resource intensive, and by default it is turned off. So when you're joining between non-collocated tables, you turn
Hmm.
it back to on. You pay, it there's a little cost to it, and then you can turn it back to off. Yeah.
Okay. So what about the reference tables joins? So
You can join the reference table as I mentioned, that reference tables are duplicated across all the worker nodes because they are reference table. The only thing to remember is that your reference table should be small. They should always be smaller tables that you reference. If the data set remains fixed and it's not very dynamic data sets, and those are good candidates for reference table. In fact, we have published a guidance in Citus Doc that when you're designing your application on Citus, that what tables are good for distribution and what tables are good for referencing. But yes, you can always join on reference table. Yeah.
so that's great session, Varun. This is a good information for how they can create for reference tables. How can use for all the dimensions within the fact tables.
Sure. So at this point, we have a little knowledge check going on. I wanted to see that, uh, Kalai, let's see. I'm going to go to the knowledge check, and we'll give some time. Let's say 2 minutes, Kalai. And
Yes.
so this is the first one, uh, which is why must a value for distribution column be specified when loading the data into a distributed table in Azure Cosmos DB for Postgres. So we have three options over here. Again, if you want to take a quick poll, you can do poll over there. Just scan the QR code. Uh, the option A is coordinator node uses the distribution column to correctly identify the shard into which the data should be inserted. Okay. The option B is the distribution column for distributed table is always primary key field, so it must be included to ensure uniqueness. Okay, think about it. Uh, the option C is metadata table on each worker node performs local lookup using distribution column to locate the correct shard for requested data. Again,
Let So we can give some time, for 2 minutes to choose the answer, and I can go through the right answer and explanations.
yeah, for sure. Yeah, again, like there's no
Right.
point deducted for right or wrong. Yeah, uh, it just tells us, me and Kalai, if we were able to do our job and explain you correctly. Uh, so yeah, it's mostly our reflection. Uh,
Okay. So this is the time to you know say that answer. The answer is A. Option A is the answer. This is the correct answer. The reason for option A is each row is the distributed table is written to a shared based on the value of the distribution columns. The coordinator access the rows distribution column and compare the hash values to the to the assigned hash range for each shard. The comparison, correctly we can say that the sharded, identified into their data should be inserted, which data should be inserted. The right answer is option A.
Awesome. Perfect. I hope most everyone should be able to, yeah, this one was pretty easy. Let's go to the next question in the knowledge check. So the question two is, what is the most performant and recommended method for executing insert slash select statements to ingest data in distributed tables? So pretty much the module two or module three and actually module one also where we discussed. So what is again the question? What is the most performant and recommended method for executing insert and select statement to ingest data into distributed tables? Option A, three options we have. Pulling the data to the coordinator. Okay. Second is do a repatriation optimization, and third is using co-located source of destination table. I'm tempted to give a little hint. Repatriation had a little penalty that we discussed, which is why it was not enabled by default. So
Correct.
may not be the best performant. Okay. Uh, Kali,
Yes,
whenever you are okay, you can go with the
yes.
answer. Yeah.
The correct answer is option C, using co-located source and destination tables.
Awesome.
The, the reason is in the coordinator to push query executions down for the parallel execution on all nodes. This push occurs when the source and destination table are co-located. When you do for insert or select statement, both included the distribution columns.
That's
So
right.
yeah, the correct answer is the C, using co-located source and destination tables.
Yep, yep, that's the right answer. That the co-located architecture, most of your classic real-world application, when you're using a distributed architecture, most of your queries will should be running on the co-located, tables, source and destination tables. These two repatriations and pulling the data to the coordinator should be left for minuscule queries, which are, which are not really running all the time. Okay, down to the third and the final question. Uh, Repatriation joins are disabled by default in Azure. Okay, in Azure Cosmos DB for Postgres. What command should you use to enable them? I think we just did it. So probably the easiest one. The
Yes,
command again options are set citus enable repatriation insert select to on the select citus enable repatriation joins to on, and the third is select, and third is actually if you see it's a function, select enable repatriation true.
exactly. The function is not going to be the right one.
Yep,
The
so
reason
which
is function is not a, you cannot enable with the functions. So
that's a good hint, Kalai. So we are now down to two options from A, B, and C. Now we only have A and B.
yeah.
So again, Kalai, whenever you're ready, feel free.
Yeah, the right answer is in option B. Set site as enable the repartition joins to on.
Yep,
The
and
we have run through this command through our we show that command how we can enable for repartition joins. It's very easy, and answer is the B.
awesome. Yep. So we are down to, we're down with these three questions, and we have, these three knowledge checks done. I am not keeping a tally, but I am super confident most of you would have got it right already. So
I can
we,
summarize,
yeah,
maybe what we so far what we covered.
go ahead, Kalaya.
Yeah. So we there are many techniques how we can insert in insert the tables and data to the tables and PostgreSQL. That's one. Identify data injections. The techniques like when we use this techniques is through the simple command and also used for bulk load. The data come from .csv file or any other file format. Also, we can use data injections from Azure's data factories also. And there is other way we can use the tables or the data. You can keep it Azure storage, blob storage. From the blob storage, also you can insert your data to PostgreSQL. That's what we have covered for the first portion. And the second part of this exercise, and also we have shown that all the queries, like how we can distribute data into Cosmos DBs, for PostgreSQL, how we can distribute the data, and also with how we can control for all the nodes, how can share your data and node and worker node and control nodes. The final one, the views data distribution, how you can created the views and how you can enable your performance, like query performance and query executor, all those things. The three major portions and exercise so far we covered, and we hope this is very good starting point for learning Cosmos DB for PostgreSQL, and we would share for all this the URL link where you can learn more things, and also we could share with this document and you would be helpful for learning more details.
Yep. And then at this point, adding on to what Kale explained, that Azure Cosmos DB for Postgres, we have the entire learning module. There's only one module that we've covered, which is today, which is the ingesting and querying the data using Azure Cosmos DB for Postgres. Uh, Obviously, you can go and, now that you've done, and if you're following this module, earn your credit. You can just, go and make sure that all these checks are okay for you once you try it out. But there are these other important modules, which is how to model the data for Azure Cosmos DB for Postgres, and then extend the functionality for Cosmos Postgres using extension, manage performance and availability, scale from single node to multiple nodes, design multi-tenant SaaS app. So we encourage you, and I believe that there will be more live sessions which will be coming from more of our colleagues, on this, on this whole learning path. So if you're again following this, I'll say, follow all the other learning paths from there. Uh, for all the resources, we plan to share, publish the slides, and the slides will have, all the scripts embedded. Everything which we showed you is right over here in each of those slides. Most of the scripts that we ran, so feel free, to try it out. So all those scripts and resources are there. And then again, we encourage you to complete your interactive learning experience, watch the videos, and most importantly, like practice and apply the new skills, right? Like I believe, irrespective of whatever we teach, if you just go and just try it out, even if it doesn't work at the first place and second place, and then third time it works, if you try it out, you'll definitely get a better hang yourself. Uh, and then we have, the next session, which is on June 28th, happens to be, I believe, next week, same day. I don't know. It's probably the same time, 10 a.m. Pacific. Is the session on extend the functionality of Azure Cosmos DB for Postgres using extension. Again, it's the session in the same series, So yeah, continue this journey of learning with Azure Cosmos DB for Postgres. Kalei, back to you if you want to have any closing remarks.
I think this session is going to be continued a couple of weeks. The next week would be June 28th, and the following another 3 more weeks you can complete for the entire sessions, and keep learning for the new skill set and the new things. Happy learning for everyone.
Yeah, and I'm going to come back. to the StreamYard and then see if there are any other questions, which I may have missed or not answered. I'm just looking at my StreamYard chat because we have like couple of time. Let's see. So I'm just reading through some of these questions. So one question is from A and V, does it provide a simpler commands than Oracle? Does it provide simpler commands than Oracle SQL? Okay. Well, again, like I've used Oracle, but somebody else, on this call, I bet is much better Oracle professional than me. But I believe Oracle does not inherently have a distributed architecture. It will have probably a different hacks to it. Uh, just like Postgres by default is not distributed, but when you apply, when you use Azure Cosmos DB for Postgres, which uses our Citus extension, that's how we make, a relational database work like distributed. So commands definitely are not same; they are different. Uh, I can't really say whether they are simpler, more complex, or less complex, but they are different, because you have to do something extra to convert a relational database into a distributed database. So especially things like these things that which we saw in the first place, like you create tables, that's pretty simple. But then you go ahead and you use these functions like create distributed table or create reference table. These are Citus specific functions, and if you're doing it for the first time, I would say you will see, okay, well, that's an extra step, uh, and they probably will not be there in Oracle. Yeah. So again, they are different, but not really. I'm not sure about simple. Uh, is there anything else?
I think mostly you covered for everything, so
Okay, awesome,
I
awesome,
did not see any other questions. So
perfect. I think then that's all we have. I think it's time for us to say bye to you and
thank you,
uh,
everyone.
yeah, thank you everyone. Again, thanks for taking time to listen, be here. I'm going to scroll back to the first slides. If there's anything which you have questions from me and Kalai, these are our social handles. I'm going to increase the font size. That's our LinkedIn and that's Twitter. Kalai, do you use Twitter?
I do, but
Okay.
I'm
Uh, Feel free, to paste, otherwise LinkedIn obviously is a great forum. So if you
not.
have questions, please feel free to reach out to us. Or we really reply and look for the feedback or whatnot, and we can like this is not a one end dialogue, so we can continue to be connected and answering your questions. Yeah.
Thank you, Varun.
Okay.
Thank you for everyone.
Yeah. Thank you, everyone. Appreciate taking your time today. Have a great day and happy learning. Bye bye.
Thank you. Bye.